So this is the parallel track, rather than serial track in the other room, and we'll be hearing about metrics-led development.
Hello. Hey. Right. Excuse my nervousness. Public speaking is not one of my strong suits, so if I start shaking and running under the table, just bear with me, let me breathe, and come back. Metric-led development, or when should you start monitoring? First thing, a couple of words about myself. I've been working in IT since 1999. We used to party, but I didn't drink then. I'm an Icinga team member since 2011. Father of two. I love dogs, as you can see from my logo. I'm a crazy cyclist, been around here with cycling, and I drink a lot of whiskey. If you have questions about whiskey, find me afterwards, we'll talk about that. Metric-led development as opposed to test-led development. Who's the developer here? Raise your hands, please. Good. How much of you actually practice test-driven development? So what I'm going to say now in this talk is going to upset you a little bit more. Test-led development, as you all know, code, write the test, CI, and we push it onward. Metric-led development, you write the code, you do the test. You start monitoring the changes, then you push it. Not the same, and I will explain why. As I've just said, sorry, you write the code, hello world, very complex. It took me 2 months to understand this code. Then you write the test, another 2 months. And eventually, we got this nice lovely word. Code, CI, server, test-led development. We know how to do that. We've done it. We're doing it. Well, here's the difference. When do companies need the monitoring? Anybody not encountered any of those? Raise your hand. So the majority encountered these scenarios in their work. A client calls about a problem. You're unaware of it because you never tested for it. You're in staging pre-production. All of a sudden, your traffic spikes. Everything goes haywire. You don't understand why. You're going into production. Things go haywire. And we'll see some examples of those later. And of course, management wants to know about their SLA and what things are going wrong. And then you're standing there in the data center saying, what the hell am I doing? Why do we need monitoring? I don't have to answer that. You know all those answers, right? Especially those ones. You come into production, you push your code, crash. You didn't test it. You tested it. You didn't actually test the effect it has on your servers or on your network. Or you didn't protect your network. Why do you want to be monitoring? This is the main reason why we want to be monitoring. We want to be proactive. We want to be able to predict when the issues will come, when the client is all of a sudden, or internal or external, will say, wait a minute, something isn't working, something's wrong. Where is the problem? Things that happen when we hit production. This is a bit exaggerated, as you can probably imagine, but tell me you haven't encountered an issue where you went to production and all of a sudden you got a spike and your server is just dead on arrival. You loaded your new version of software, you tested it with your data set. Yay, it works. You load it into production. Nothing works. You never tested it to that scope. Network spikes. You expecting it to be 20 users, 30 users. You have 2.5 million users. Your network doesn't support it. Your servers can't support it. Your switch is overflooded, or you just didn't configure a switch correctly and you have a TCP storm. You suffered. So when should you start monitoring? Is it in QA? No. Is it in load testing? No. Is it in end-to-end testing? Again, no. Is it in staging? No. This is when you start. You start after you wrote your first code. You write your code, then you want to understand where it actually affects your system. Because as those of you who are coding here, you notice, you write a code, you check it overboard to the ops, you write the code, and all of a sudden you see the spike and the forking and opening of files, but it was never tested. And let's hear the number one excuse of developers. It works on my Exactly. It works on your laptop. Yay. What's your data set?
Good for you.
What?
Good for you.
Good for you. You tested it with what? 10 connections? A data set of, I don't know, a database of 2 megabytes? We're running a 2 terabyte database. That one hole, that SQL query will crash the server. So this is what we're talking about. Test-driven development and metric-led development. You write your code. You write your test for the CI. You write your monitoring plugin code, if you want to call it, or the monitoring test. You push it into your test, and then you get that. Oops, sorry. Then you get that. Unable to work. Why do we do this now? Send it back to development. It doesn't reach production. It doesn't reach anywhere beside your own testing environment. You know something is wrong. You know the server can't actually cope with that. So we send it back. Why do we want that? We want what, all right, sorry. Why do we want that? I just explained. What do we want to monitor? I will explain what these are. These are your legacy servers, your legacy switches, the temperature in your data center, your firewalls, your PBXs, and your user experience when something goes wrong. And of course, the most important thing is how much beer there is in the fridge. Because when you're doing an all-nighter, you want that beer in the fridge and you want it cold. What you don't want to monitor. When you start monitoring, you're monitoring a lot of things. But the obvious things should be monitored. In the previous edition of this talk, which Bernd saw last time, there was, I don't know, if some of you are more inclined to the scientific community. 2 years ago? It was 2 years ago, yes. There was stage 3 of an experiment about the thickest liquid in the world. It started in 1941, and the third drop actually dropped 2 years ago. And it was broadcast live. And the guys were standing there for 20 minutes waiting for it to fall. That thing you don't need to monitor. The job of the guy was to come into the office, look at it, and walk away. For 20 years he was doing that. We don't really need to monitor. We also don't need to monitor the clock. We monitor the NTPs, yes, but the old grandfather clock, no need to monitor, right? This is a case study that I did in the, who here remembers the DMI fiasco in the BBC? Guilty as charged, I worked in that one. Yes, I grabbed some money of the taxpayers. I built them the monitoring solution. They started with Xenos. I got nothing against Xenos. It did its job for what it was needed, but one of the major things that it had a problem with, no dependencies module. Who here worked with Nagios, Icinga, naturally, or any of the derivatives? Good. Dependencies, brilliant stuff. One thing doesn't work, we don't want to get alerted about something else, right? That depends on it. Xenos didn't have that. It was to be released in the next version, and you have to pay for that module. BBC decided, no, that doesn't work. Let's build a solution that will give us the functionality that we want now. I was trying to convince them to use Icinga 1, because it was out at the time. The rest of the BBC was using Nagios, so they chose Nagios. So I built them as a 3 data center solution with 67 servers in each data center, 6 petabyte of storage for each location, and 12 remote sites with 24 servers in each remote site. High availability in each data center. Maud Gearman as the distribution venue to go, or you're in one data center, you're monitoring your data center unless something falls over, and you're monitoring the other one. Puppet provisioned. Basically, everything was automated. We didn't have to manually bring everything up. Once we set it up once, puppetize, and now it's automated. We don't want to work with it anymore. And I built a very convoluted method of data center detection of if this one falls, who takes over the other chip? It was a complex code that relies on latency and closeness, distance from W1. And then they asked me to activate it for W1. They wanted to see all the alerts they're getting. That's just W1. This is what they got. Now, we had 3 data centers. They decided, no, don't activate the other 3. That was because they asked me to monitor the entire scope, and they already wanted to productionize it without finishing product stage first. we had so many problems with the code that they haven't started monitoring when they started writing it. That was the result when they started sending data and sending monitoring. Can you imagine how long it took them to ask me to stop?
10 minutes?
In the 4th minute, when they started getting the floods, now this is 4,000 per one person. And this was sent to the management team.
Let me guess, there was an alert from the email system shortly after?
No, thankfully no. Because we were in a closed circuit email. It didn't go out to the BBC emails. That was good. We had our own infrastructure for emails. After the 4th minute, when they were unable to stop the flow, they came to me and said, stop it. I did. I was nice. Now, how do you go about deciding which tool to use for monitoring? You do the market research. There's so many tools you can use. I'm biased towards one. Bird knows that one. But you have to choose the tool that fits what you need. In the old days, you could have used Cacti for your SNMP monitoring, and now you can do other tools. You always have to do whichever is suitable. You do the market research. You also do it choosing by your budget. If you're a small startup, that's your budget. So you can't go and invest something in App Dynamics, New Relic, and all those big platforms that charge you by the pound. You can't. You can't afford it. So you go to what you can afford, which usually ends up in open source, or usually ends up in some scripting that you're writing because you need only this and only that. But you can do all those three. I wouldn't recommend this one for a small startup, but I would recommend going with that for a small startup, because they are very cheap, like Pingdom, that can give you the minimum one you want, and you can get what you need without having to break your head about it. However, another case study that I did, I think I mentioned it to several people here that I worked for Sky, specifically the cloud when it was named that one. Then it was Sky Wi-Fi or Sky Business now, don't remember. They used Nagios. Again, I was trying to move them to Icinga, and they were sending this amount of alerts each night. This is what happened one night when one of our colleagues decided, I'm going to sleep. We replaced the phone the other day, of course, but I actually, when I was on call, I was living in Hemel Hempstead at the time. The phone used to be in the bottom floor. I used to sleep on the top floor. If it didn't ring as a phone, not just emails, I didn't answer. We were just not paying attention. This was a night. Imagine how many alerts we used to get through the day when there was traffic on the system. Can anybody want to venture a guess?
400,000?
No, that's exaggerating. 5,000 emails. 5,000 during 24 hours period. Anybody of you think that he will actually respond to a phone would get 5,000 emails for an alert in the night? Raise your hand if you think you are. And I would be good.
And how long did that situation go on for?
Prior to me arriving, 2 years. So what I did, I removed flapping detection. I removed known false positives. They had those for so many years. False positives. Why do you want to get an alert for that one? Oh, we want to monitor everything. Really? Do you want to sleep at night? Remove deprecated alerts. They had alerts that were invalid for more than 9 months. They were acknowledged, some of them. Some of them were testing twice a day, but they were deprecated. When I actually went to investigate them, there's nothing behind them. It's just tests and send an alert. Why do you want to get that? And especially it was annoying because he was checking the backup at 3 o'clock in the morning, which was no longer running because when they were incorporated into Sky, Sky moved them to their own backup system, not the internal, but they just, oh, we acknowledged the alert, then forgot about it, then it went back up, and it's not just sending an email once a night. No, it's not. Twice, because it fails twice. Oh yeah, it didn't work, now it's okay. So you wake up twice. And that. Anybody want to venture a guess what was the result 2 weeks after I did all these steps.
They changed the email address without telling you?
No, they fixed the code. That is what happened. 3 alerts a night. Maybe.
What's flapping detection?
Flapping detection is a tool that incorporates in Nagios and Icinga that if a service or a check is failing and coming back frequently within 15 minutes or other threshold that you define, it lets you it alerts you, letting you know that it's flapping, going up and down, up and down. It's unstable. It's in some cases it's a very good check. In that particular case, it was annoying because in some cases when you're monitoring CPU usage, flapping can be very, 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 very problematic. Oh, we got a spike, we're going back to normal. We got a spike, we're going back to normal. If that's the behavior and the pattern of your system, you don't want to be alerted about it. If it's something that is not a pattern in your system, yes, you want to be aware of that because something is causing spikes on your system, you want to be aware. But if that's that's the pattern of your system, you know that's the way it's working. You tested it before, right? That's what we said. We're testing it in production, in development. Now, you don't need to know about it in production because that's the way the system works. Right, so, wow, I'm running fast. What do we need to, who do we need to connect the monitoring to? Like I said, first of all, that. Oops. Add the developers to the alerts. This is why I said the developers here won't like it. Because that means, first of all, you have more work. You need to write to find out. You're adding a new patch of software. You need to write the plugin or the test for it to be monitored and tell, not just, yeah, it's okay, or something that, test it and that I don't care about the response. Because if there's an ops person here who will actually code review it and say, oh, it monitors and it returns okay no matter what, they should reject it and send you back home. Tell you, fix it. Most often, the person who wrote the code will know where to look for it. One of the major issues is who works in Java? Who works in Java here? Right. So you would understand better than an ops person what the Eden, what the GC, and what the GMX parameters to look for are, right? If you throw it over the wall to the ops guys, they will come and bug you for who knows how long until they get it right. If you write it day one, they'll get it. You'll sleep better at night. They won't bother you. Everybody's happy, right? So when you're building the monitoring, don't let the ops guys be the one taking the fall, especially not management. Let the devs take the fall when it doesn't work in the middle of the night. They'll wake up. Usually, or in your companies, how many of the developers are actually involved in getting alerts and being awake at night? You do. You do. 3. How many are we in the room? That's 5 out of nearly 20 people. Less than 20.
Some of us might not be relevant to this calculation.
Might be. I completely agree. I know that in the companies I consult with, I don't get the alerts. I set up the monitoring, I don't get the alerts. One of the benefits of being a consultant, right? You don't wake me in the middle of the night because you don't want to pay for that. But you do want to make them incorporated into the monitoring systems. First of all, it will encourage them to write better code, write better monitoring, and be more aware of what they're sending over the wall. Basically, we want to abolish that wall. We want to make sure they're incorporated into the entire scenario of developing the code, testing it, making sure it runs in the monitoring, and then moving it into production. It's a paradigm shift that will require, it'll slow down development. Yes, it'll slow down time to market because you need to test it, you need to evaluate it. But it'll be beneficial for the company in the long run. Capabilities. When you're starting the monitoring, you need to decide what capabilities you want in the monitoring tool. I always like this one. Always. And every time somebody comes to tell me, but this tool isn't working, the monitoring system doesn't do this. And I said, well, you didn't design it, you need to check, and let's check it out now, bring it something else, or we can write for it. I've been talking to people about Prometheus and their metrics, and people told me about Rayman, or whatever it's called, and a lot of other tools. And they told me that Icinga cannot do those things. And I thought, that's incorrect. It might not be suitable for your specific needs, but it can do most of what you need. Maybe it's not 100%. But if you want SNMP, yes, go with Cacti, go with something else, go with Xenos. But always check what tool is better suited for the functions you need. If you just want to monitor web applications, take something simple. You can just write a curl or go ping them, or there is some other distributor, I forgot the name. You always want to do those. Check which one you want, because if you want distributed monitoring, for instance, Nagios is not your thing. It's not distributed, it's not high available. It's good for a small company, 9 to 10 servers. You set it up. Most likely you have somebody who played with Nagios, you can set it up in 10 minutes. But if you want something more, you need something more robust, something that allows your integration with your CI, with your Git, with everything. And that in this case, it's not Nagios. Database. Oh, don't get me on database integrations. Most engines don't write themselves very well into databases, or the databases just explode. If you haven't encountered that, you probably didn't monitor enough. When I left,
MySQL comes to mind.
yeah, MySQL.
Time series data that grows.
When I left Sky, they were adding servers, and because the developers were we shifted writing the plugins to developers, they were testing everything. And when I mean everything, they were testing the GMX into 1,000ths of a second, 100th of a second, 500th of a second, and all those kinds. 180 checks per server, and we had 10 of those. And it was all writing to a database, and it was all extrapolating into graphs and everything. It became a monster, and then I told them, nah, you need to slow down. Nagios won't be able to cope. And of course, the database exploded. Support. When you start monitoring, support is very important. The community is a wonderful thing, but sometimes in some places you want something more than that. This is where consultants come in, partners, or if you're going for an enterprise-grade solution, you need to know what the budget is. Professional support is good. It pays for my bills. I have to say that. But not every company can give you that, and not every monitoring solution will give you that. We can think of several places that don't have professional support, professional monitoring tools. Again, I'll go back to Cacti. Cacti doesn't have monitoring professional solutions. Sensu, as far as I'm aware, does not have it also. Elasticsearch or Elastic does have something, but I haven't heard of anybody playing it. So you need to define this. If you want to rely only on the community, it's good. A lot of people do that. But you need to be aware that not every problem that you have with the monitoring can be solved with the community. Sometimes you'll have to get your hands, what I call dirty, and change the code yourself to match what you need. Use the tool you know. That should be obvious to everybody, right? If you know a tool, you used it, you implemented it in several other places, and you can set it up quickly, start with that. Don't wait until somebody in the ops team or in the DevOps team or in whatever says, oh, I'll go learn that later because now we need to do right X. You have the knowledge, set it up, start it. Once it's there, like a CTO of one company that I worked with says, once it's there, you get the hunger for more. Oh, we get the visibility for this, and I want that, I want that, I want that, I want that. So once you have a basic setup, it'll only grow. But if we planned it properly in the beginning, it'll grow bigger, better, and it will adapt itself to the platform you need and to the code you're writing. How easy it is to start? I shouldn't explain this, right? You can get yourself with Vagrant. There's Vagrant for Icinga, there's Vagrant for other stuff. Docker. Simple as pie, right? No, that's not there. But you just type Docker run Icinga specifically, or you can run anything else. You install it, you run it. It's easy. You can go to, if you're on Amazon, you have the CloudWatch. If you're on Google platform, they have the Stack driver. Yes, that's it. And or you just, and of course there's New Relic, and you can just bring yourself a VM that you can download, and you're up and running. There's no need to buy any dedicated hardware if you're still working just with hardware or bare metal, right? You can put it on your own laptop. You come into the office, you activate the VMware, and you're monitoring your test environment because during the night you're not working, so no need for testing it. But it's that simple. You can be up and running in, well, if my demo will work, in 17 minutes to start monitoring your system. That is including provisioning the servers in the Amazon. I'll see if I have time for that demo later. But it's simple, it's easy, it's fast. There's no reason not to do that on day one. You bought a hardware, start monitoring it. Even if it just pings, you know what your latency to the server. Because eventually, if you're overclocking the server, ping will slow down. So, this is what we're talking about. Hopefully we'll not get that. But this is the metric-led development. Because this will allow you to do the calculation. We want to write the code, push it into the Git, do the CI, push it into monitoring, and then be able to know if it's working. Conclusion. Wow, I am fast. You start monitoring early. Like I said, day one. Day one, you wrote code, you test, you're monitoring it because you don't want to see any implication of why it's not working. You get it from day one. Involve the dev in monitoring, like I said. It's crucial. Writing the monitoring after it's in production or after it's in staging, it's too late. You'll hit the problems that we saw with the spikes, the crashes, the slowness. Make it part of the CI. I've reiterated that one. As much data as possible. Why do we want as much data as possible in CI? Because you wrote a piece of code. It affects the CPU, it affects the I/O, it affects the memory allocation. You do that with a, like I said, 20 meg data set. You know that your production is X times larger. You take the performance data, you extrapolate it. You add about 20% on top of that, just for variations, because the hardware that you have in the test environment is not the hardware that you have in the production environment. And then you can tell the management, servers won't hold. We won't be able to support the amount of traffic or the amount of requests that we are seeing with that code or with that hardware. And most likely when you show a graph to the management, they'll say, oops, yeah, we need to talk about that because we can't push it into production. So you can plan it ahead and you can warn them ahead. And then there won't be the 4 a.m. wake-up call in the middle of the night when, nothing works, the client is upset, or we're losing money because nobody can connect to our website. Always plan ahead. And that's why we expose the data to management, like I said, and always highlight abnormal occurrences. The individual spike in the middle of the night is nice. Sometimes, yeah, we hit 5 million traffic. Why did we hit 5 million traffic? Or why was that spike and we had to restart the server? Or why was the kernel panic? If you capture those before it hits production, we are much better off and we are able to survive and have a family life. Not sleeping on the couch because the phone rings in the middle of the night, which I assume some of you have encountered previously. Now, this is the part of the Q&A, but I will try to do my demo. So we'll go back to that one. I am always rushing this, I don't know why.
You've got 16 minutes for your demo.
We'll see if I can sort it out in that time. Demo. Where's my demo? Where is it? Not here. Just a second. I should probably drag this to here. No, I don't see it. Any of you worked with Terraform? Okay. So this, and I will put this later on either GitHub or GitLab. I haven't decided yet because the Terraform you can get, but not with micro security credentials upload naturally. But what this will do, sorry. Yeah. What this will actually do, it will create 3 servers in the cloud, an Icinga master, and 2 nodes, and the security groups to actually connect between them. So we can, if anybody wants to read that and is able to read that, by all means. It will bring up 3 servers, and once I have those IPs, I will actually put those in my host file and run the Ansible playbook to populate it. Hopefully it'll take less time than we have to finish. And meantime, while it's running, we can, oh, I need to log into AWS. You can ask any questions you want, if you have any.
I'm raising a hand and I meant to hold on.
Sorry?
I was raising my hand and realized you weren't looking. So,
Oh, sorry. Yes, sorry.
um,
So this will run, yeah.
so I've noticed that many people will do web monitoring these days, like you use sort of things like Zabbix and stuff where you have it, you send a GET request, you URL, you check that you get a 200
Yeah.
kind of thing, and you check it, you know, once a minute, once every 5 minutes, whatever, and that's great. But sometimes that page is not very representative, or sometimes it doesn't tell you a lot about the site because it's like, well, great, our homepage works. Well, what about login? What about this? What about that? And where do you stop? But also, I've noticed that some people try to add instrumentation into things like their load balancing systems or their applications, so instead you can graph things like what percentage of my users' actual requests got 200, what percentage got 500, that kind of thing.
Mm-hmm.
What's your opinion of that approach?
Sorry. Right there. You need to monitor those things. This is, if you notice that I've actually specified end-to-end testing. This is what you're talking about. End-to-end testing is important because otherwise you're unaware of what your user experience looks like. It's important to monitor that. It's important to simulate it while still in development. So you need to write the check or the plugins or just analyze the results as you do it. There are tools that allow you to do that. You can, of course, write your own checks to do that. But it's important to do the end-to-end testing. Otherwise, you come to production knowing, oh, yes, the home page works fine. But how is the PHP or the JavaScript function behind it or the connection to the database can hold with the amount of X amount of connections or with the function that the user is trying? Because one of the things that I've learned working with web applications is the users will always find a way to do something you haven't expected, and then the code breaks if you haven't tested. So this is something you have to do. You have to anticipate the end-to-end user experience and try to monitor it. If you can't do that, something is wrong with your monitoring or with your code.
We had an interesting problem where, obviously, again, we'd written our monitoring during the development phase 2 jobs ago, but and we got some test endpoint on our website which would go away, do a select from the database, it would insert a job into a job queue, wait a maximum of 30 seconds for the job to get to the end of the queue and check that the result came back, and then that was your monitoring check, whatever. And that was great until people actually started using the site and the queue got bigger, and now suddenly your monitoring check, the latency of the site was going up according to the monitoring because the health check wouldn't come back until the thing had got in front of the queue, and if there was batch reports running or something like that could be 20 minutes or something.
Exactly.
So really that's not so much a monitoring problem though, it's a testing problem where you just haven't tested.
Yeah,
it.
okay, no, I mean, I think the mistake in that case was that they were using the same queue for batch report jobs as for high QPS sort of low latency requests for sort of background jobs, which meant that the health check was assuming that of course you get your back in 30 seconds, and because they were mixing the workload types was the mistake. But anyway.
I think it's also a thing that you do the correlation between the end-to-end test on one hand, like using frameworks like Sakuli or Alivix, which can do that for Icinga or Nagios, and then probably correlate them in kind of a business process view, what happens to the database if I see the load is increasing, that my user experience drops with 10% per response time, for example, and then you get kind of an idea what happens if you have more users on the platform. It ends up in a high increase of database errors or lower result. So Alivix is a pretty cool framework to have a look on.
What is this?
Alivix?
You also do things like do actual web browsers. So you do things like Selenium to automate web browsers,
Right, yeah.
And if you're feeling really clever, you can use racks of mobile phones to do that, because I know at least one of the big cloud people do. One of the big tech companies have basically racks of mobile phones that they use for testing.
All right.
Even higher than an AWS.
Don't you think?
Yeah, it's a fairly expensive virtual machine type.
That's true.
Right. During the building of this demo, I actually found a couple of things that were incorrect in the Ansible playbook. But I'm going to deal with that once the demo is finished and submit them. Any more questions while I'm prepping this up?
Can I?
Yes.
So it struck me while you were speaking, would you actually advocate having more monitoring in the development test phases than in prod? Because you can see the value in your developers might want to alert, say, your process is now taking 10% more memory than it used to. Whereas in the middle of the night, I really don't want to be woken up to be told that something's working fine but taking more memory than it used to. So is that like sort of debug logging? You kind of actually want to turn it off when you get to prod, or?
No. And I'll explain this in a second. Just a second. Anything you monitor in dev or during the development cycle, you should be monitoring in production. However, you should be focusing more while doing it in dev. I wouldn't exclude. Well, I would exclude some testing that should never happen. But the paradigm, but the focus should be on production. Always monitor production because that's where your money comes from. But the same test that you think will be in production has to be already in your dev. Has to be, because you will get a different response. Just a second. You get a different response or a smaller data set comparison, but you will know how the system behaves before it hits the production.
But I'm asking the opposite. Should you not have tests in dev that you don't have in production? Because I want to know in dev that something's getting a bit slower. In prod, actually it's the middle of the night. I don't want to be told it's a little bit slower. Maybe the next day I want to review it and find out.
Well, that I think that's incorrect approach. You should have the same test, because if in production it slows down, that affects your user. So you need to be aware of that, because it can keep slowing down until it comes to a dead stop. So you want to be aware before it got to the dead stop.
Okay. I guess what I'm saying is the thresholds might be higher.
The threshold will definitely be different, because on your 1 core 8 gig RAM, if it goes to 100, fine. If on a 16 core 64 gigabit RAM, you still have the same threshold, you're going to be screwed, man. That's why if you have automated system, it will know to detect it. In some places that I've implemented, we had the monitoring system control, the dev and the production, and it knew to differentiate based on number of cores, number of system, which environment it was. Automated systems will allow you to know that, and will adapt the thresholds based on what environment you're going through. Yes?
So what I was going to say, I touched on there, is about sort of the difference between sort of metrics and monitoring, and whether you believe they should be the same thing, because some places will have one system to collect a lot of data about everything and only alert on a subset of it, and some people believe that your monitoring system should only collect the stuff it's going to alert about.
Well,
I guess, I found, as I've had these problems, but I found it was very valuable in the past. I'd go back and see a trend and see, oh well, the memory usage has been increasing for the past 3 months on this particular application, and only now has it crossed the threshold, or only now has it done caused a related problem, and oh look, that coincided with shipping 2.0.
No. To sum it up, I don't think monitoring and metric gathering should be different. I think they should be the same. The alerting, because if you have more than one location where you're looking at things get lost. You should have a centralized location where you're monitoring and your metric gathering combined, because then you can see the trending for your monitoring. If you don't want to alert on something, just don't. Gather the data, because being able to evaluate the data based on your monitoring, like, what's your name, sorry?
Sorry,
Gordon. Like Gordon said, you don't want to wake up in the middle of the night. But if you woke up in the middle of the night, you want to be able to approach the system, see, oh, this is the trend. Right. we've been seeing this alert going on every night for the same thing. Let's change the threshold. If it was like that, oh, I woke up in the middle of the night, I fixed it, I went back to sleep, you'll forget about the fact that it's been going on for a while. So you want to be able to, all right, yeah, this issue, I know it, it's a set thing. Let's either set the threshold or fix the underlying problem. If it's traffic, we'll raise the threshold because we don't want to tell people, don't use the system. We want to be able to tell, yes, use.
Maybe there's capacity management implications there.
But the capacity management is the metrics, and also it's affected by, capacity is also usually affected by monitoring, because that's what you do, your scaling, you bring up new servers, you increase this, you raise the switches from 1 gig to 10 gig, you buy new routers, you increase the firewall, you go to your broadband provider, tell them, oh, I need a bigger pipeline, right? It's affected by the monitoring when you slow down by your metrics. So it's all combined. It's a it's an ecosystem. It's not, nothing is in isolation. So that's why your metrics should be gathered in your monitoring, which is why this is called not when you start monitoring, but metric-led, because this is the same thing. From my perspective, monitoring is your metrics. This is where you gather them. Whether you're getting the alert in the middle of the night or not is trivial. Not trivial to the person sleeping, but it's trivial to the functionality of the tool. Now let's see if I can actually run this demo. That's a big if. Where's... No, that's not it. No. We don't have time for the demo, unfortunately.
3 minutes left, and we need to be having our next presentation.
Yes, and the demo takes building takes 17 minutes, unfortunately. What it does basically is build up an Icinga server, which Icinga server, 2 web-based nodes, and starts monitoring all the LAMP stack. That's what it does. And like I said, if you do this and in your dev environment, 17 minutes, and you start monitoring your LAMP stack. I bought this because this is what I like. If you wanted to start monitoring your Java, all you have to do is, let me just show you for a second. I'll drag this across. Really bad. You put it here. You define your checks here. That's it. You're done. 17 minutes later, you have your basic checks. Can you tell me you can't forgo 17 minutes in your day to start getting your stats? I don't think that's true.
Are you able to share your Terraform and Ansible playbooks?
I will. I will publish this. I don't know when.
Emerson is already happy, Assaf. More money.
And I was about to show you my contact details. Where if you want to contact me, why is it can't run all the way to the end? Oops. Yeah.
It was there for a second.
Yeah, that's my talk. So we're done. Yeah. No, but we'll do this.
And if you...
That's me. That's my website. If you want to, oh, that's incorrect. That's www, but never mind. That's my Twitter account. That's my Skype. You can always Skype me if you want to, and you can get in touch with me. Questions, help, whatever you need.
And if you drop something from FLOSSUK link, we will publicise it.
Oh, sure.
Thank you for your talk.
You're welcome.